That is my new bandsaw, which so far has worked out very well. It's maybe a month old. Only complaint I have about this particular tool is the fence. Could have been a little better. This is just a box of aluminum, not very sturdy, but it seems to work okay. And that is the beginning of my circle jig. We're going to go right down the road of design and building this jig and see how well it works out. Alright, there is the leftover piece of MDF I'm going to get the base out of. We need the circle jig because we need to make that piece for my potting bench for the countertop. That's shown in a different video. I decided to go ahead and get this circle jig done for this one. And there's what we need out of this piece to start off with. It's a 15 by 20 piece of 3/4. And then we're going to cut that into the end. And we'll see how it all goes together coming up. Double checking, making sure we're set 15 inches. There's the base. Now time to set up the router. I had a fan blowing in the shop, so the audio on the recording was very noisy, so I am overdubbing this one. I'm using a 3/4 by 14 degree dovetail, and the center line for this cut is going to be 5 1/8 inch from the edge. If you're going to attempt one of these builds, you will have to determine this dimension based on the table of your bandsaw. Using a combination square, I make a mark at 5 1/8 inch, and then I go get my T-square to mark it across the board. After I marked this line, I noticed on the print it is missing the length of the cut. I will have to go back to the computer and pull up the 3D model and make another print so I have the dimension how long this cut should be. I didn't actually print out a new copy, but I did mark on the print that it should be 15-inch long cut. So now I'll mark the board at the 15-inch mark from the opposite end. The 15-inch dimension isn't actually critical, but it should be close. The 5 1/8 dimension is critical because it needs to be centered on the cutting edge of the bandsaw blade. I will be putting in an adjustable stop so I can make certain that that dovetail cut is going to be centered right on the cutting edge of the blade. There's going to be what I'm calling a carriage that rides in that dovetail. At the time I'm laying all this out, that carriage is actually printing on my 3D printer. Let's take a trip inside to see how it's doing. Here's the 3D printer diligently doing what it's supposed to be doing. These are the three pieces that make up the carriage assembly. In the front I'm calling a donut, which kind of looks like a donut. To the rear and on the left side is a puck that the donut rides on, and to the rear on the right side is the carriage piece that goes into the dovetail. This is going to be a 2-hour print job, and all these pieces will make much more sense when you see the whole thing go together. There was a lot of fan noise on this segment as well. It must have been a hot day. Based on the dates of the files, these were done in August last year, and I am just now getting to publishing it. Now setting up on the router table to cut the dovetail. I have the router bit loosely set in the collet, and the fence held down with spring clamps. That is a 1/2-inch shank router bit, and with the dimension looking through the center of the cut at 5 1/8 inches, we have to subtract half the diameter of that bit from that dimension, giving us 4 7/8 inches to the fence. Backing up a bit, we can see the setup on the whole table. The spring clamps will be replaced with hard clamps once I'm ready to cut. Now that I have the fence set, it is time to replace those spring clamps with a hard clamp to prevent the fence from moving. Again, I use the spring clamps because it makes it easier to tap the fence over with a hammer one way or the other to get it set at the right position. Also note that I regret the purchase of this particular table, but it's the only router table I have. Now that the fence is firmly clamped down, I need to find myself a piece of scrap to set the depth of the dovetail and do a couple of test cuts. Now I've got my depth gauge out to set the depth at 11/32. Pushing the depth gauge down to the top of the bit and holding it down with my finger because that's an aluminum base so the magnets don't work, I raise the bit until I get to 11/32. Once there, I pull up the gauge and then push it back down to make sure that it is in the right spot and then lock down the router. Now I've got to run off and find that piece of scrap. That needs to be about 6 inches deep. This is actually going to be the second test cut, as the first test cut was horrible, and you'll be able to see that in the image coming up because I'm using a piece too narrow for what I'm doing and it rocked on the fence. This second attempt I got a good straight cut, and I'll be able to use this to gauge whether or not the setup is correct before cutting the larger piece. Sorry for being a little off center, but here I am lining up my test cut on the baseboard to validate that the center line on the baseboard is in the center line of the dovetail cut. Also validating that the depth of the cut is good, but now I've got to wait for my carriage to finish on the 3D printer to make certain it slides through the cut. I confirmed the 3D printed carriage fits through the test cut, so now it's time to cut the dovetail on the baseboard. Reviewing the router setup, making sure the bit is centered on the center line of the baseboard, and then getting ready to cut. I'm sorry about the shaky video, but this is difficult to do one-handed. This crappy aluminum table on this crappy router table has a lot of friction on the MDF board, so it wobbled a little bit during the cut. I had to run it through twice to make sure I had a straight edge, and I'll have to repair that later. I'm thinking I'll be able to lay some plaster of Paris in there to smooth it out for the carriage. Okay, starting a tap straight in steel, or in this case, tapping through plastic. You want to get that tap at 90 degrees. It's practically impossible to do it by hand, and tapping high-speed taps are expensive, and the machines to run them are expensive. So this is what I do in my drill press. I've already disconnected the drive belts, so this is free spinning. So I just drop it in without putting, I don't know if you can't see my hand on the lever at top, won't move, but without putting any downward force, just relieving the upward spring force, I just start my way through. Looks like we're going to need another clamp on this one. I think there would be that much force, so let's get another clamp on there. And again, relieving the spring pressure so that the tap just pulls its way through. This is about as far as I've ever gotten into steel before it spins in the chuck, because it's not a 4-jaw chuck, it's a 3-jaw chuck, so it's not properly, the bit's not properly held in there. But for plastic, we can go all the way through, and we should be all the way through or very close now. So again, no spring pressure, Just relieving the spring tension, letting it come all the way out on its own. And there we go. Probably won't be able to focus on this. There we go. Nice threaded hole through my carriage. So now let's get it set up. Here's how it's going to work. There's my carriage assembly. This and the screw's too short on this one. We're going to make another one of these that insets. Here, let's get a close up on this. It's going to inset that bolt in a little bit further, so I have more threads coming out the bottom. Right now there should be just enough to engage this. This slides in here, and because of the wobbles it's too tight. To run that through. This first section here is a little wonky. We're going to have to touch that up, but we can see we can slide through right here just fine. So what we do is we set the distance from the blade to the center of this. We tighten this down. Can't go too tight or I'll pull the threads out because it's too short. That locks this in place. This piece gets double-sided taped to the blank that's going to be cut out. It gets dropped onto here and rotates like so. And that's our circle jig. This is going to get screwed to the end here, and that is essentially the stop where this is going to stop going up. So that's how this thing's going to work. I have to clean up this slot just a bit right here at the beginning. And everything will be ready to go. This scene is pretty uneventful and boring. I have 2 pieces of poplar and I'll be trimming them down to 1-inch boards. Then I'll take them over to the bandsaw and trim them down to a 1/2 inch thick. Okay, here we are at the bandsaw. Not a whole lot of light on this end. This is a crowded corner. I do not trust this gauge. It is not correct. I need to get under there and route out the slots so I can get this to be able to adjust correctly. We're going to want a 1/2 inch deep, and that's close. Here I've got a piece of scrap stock. We're going to run that through there and see how close we are to a 1/2 inch. I use whatever I can as a push stick over here. We are cautious of bandsaws. I almost took a thumb off in a bandsaw a number of years ago. Let's see where we're at here. If I'm not looking in the camera, I'm hoping we're holding that here. And I'd say we're at a 1/2 inch. I don't think that's going to focus for me, but we're good at a 1/2 inch. So we're going to set up a little bit better of a guide this time. We just got a chunk of wood here. We're going to put it up. And that clamp won't go around that whole thing there, so we'll just do it this way. Get a clamp on here to hold it. Make sure it slides easy, doesn't wobble back and forth.
careful with this one because this is not 3/4. I have to make sure I'm cutting on the 1-inch side because they're very, as you can see, they're very close. Make sure I'm cutting on the 1-inch side to get me a 1/2-inch piece. I had a guy once tell me he asked me the simple safety question, and this was actually involving table saws. At what speed is it safe to get your fingers close to the teeth of the table saw? And it was the same apply here. And his answer was when you can count the teeth on the blade, because I guarantee you can't count them until it is stopped. Here's my 2 guides and 2 pieces to cut off.
First get this one, and I cannot tell the grain pattern on this piece. Appears to be going that way.
Okay, here we go.
Do a quick inspection on height. I cannot feel the difference. A little sandpaper to clean those up, and they'll be ready to one pass on the crosscut sled. And now I've used this edge as the guide because this was cut on this edge. So now we are in line. So let's get this set up again. This here, here. This piece should now be square to here. Now we can put in this clamp locating this side. Put in a clamp locating the top piece as it sits. See if I'm still square. Now this side came up a little bit. You go find my dinking hammer. Small hammer to line things up. Now we are square. Get this one's locked in place. Everything's still squared up. Now we can clamp this one in place. And hope difficulty is not in this, because we can see I can still spin this easy enough. Everything's still locked in place there. Work this back and forth a few times and that dovetail should clean right up. And we tighten it up and it's locked in place. So everything looks square. So this is all ready to get glued up. But first, I'm going to cut the runners that go here. That's half. These will be MDF, 3/4 by half deep. Same thickness as these here, 1/2 inch deep. For runners for the flat place. There's no reason for this whole surface to be solid. This is going to be sitting here and rotating, and all it needs is runners out here to prevent it from tipping. If the whole thing was solid, it would be much heavier, much harder to move around, so all we need are pieces on the side. We're going to put 3 of them here, one against the edge, middle. We're going to have 1, 2, 3. We're going to have 1 on this side, and there might need to be 1 that goes across there. Haven't decided that one yet. A few form pieces to cut up. Get the miter glued to the bottom. Get my runners cut, and next step, time to dig out some 1/2 inch MDF for the runners. Wood pipe. Okay, we've got some 1/2 inch MDF. 3/4 inches, just small enough for my fish sticks. There's trouble. There's what we've got. All the top pieces are cut. I am going to put another one across here, just like so. I think that'll be wise. These corners here will be chamfered, so if an edge gets up to them, they'll slide up on top. I haven't put in the chamfers yet. And sitting on top here are the 2 pieces that'll be for the miter slot. I didn't have a scrap piece of poplar long enough, so it'll have to be 2 pieces. And I will line them up by actually putting them in place on the bandsaw table. So everything, make sure everything's perfectly lined up. So next up is some glue. Alright, here's our test clamp for gluing. Got my little square, keeping this piece square to this end, which is square to that end, keeping these 2 parallel. I've got a piece of paper folded in half as my shim, keeping everything up tight against the shim. Let's get this up even with the end. Make sure we're still square. Making sure we're tight up against the shims, and that's how I'm going to set it, or at least I think that's how I'm going to set it up. Now, without disturbing the clamps holding everything in place, we pull the shims
Going to leave those two there and make sure we slide without running into anything. We still have to clean up that dovetail. See if we can slide front to end with more than enough clearance in there. So this is how I'm going to set it up. We got more than enough clearance, sliding that back and forth. So now I'm going to pull everything up and get some glue in there before going to the next step. Actually, before I glue it in, I'm going to go ahead. You can see this piece here I've got set up for a couple of flathead screws that are going there. We're going to go ahead and drill and screw that one in place as the main guide for everything. With the two shims in place, holding it center, we're going to get that screwed down. Then we'll glue in the two side plate or the two guides, and after that come all of the supports.
With the spacer in place, I use a drill bit the size of the shank of the screw and put a small dimple into the base plate. Then, moving anything out of the way, I use the proper size drill bit to drill the pilot hole to the size screw. Now, screwing the spacer down in place, I do the exact same thing for the other side, making sure that both screws are lined up properly. Shims are snug. I'm running out of battery here real quick. It might die on me, but now that that's in place, we're going to make sure and I don't have the shims in here. I've got to put the shims back in this side. Make sure we're still square. And one of my paper shims seemed to have blown away. There it is. Make sure we still have free movement other than the binding. Once it gets to a binding spot, I make sure I can still rotate this easily, which means it's not up against the sides, and there we go. We're all set to glue in place. Everything is ready to glue up, and I have everything prepared. Glue's on the board, the guides are on the board, as well as the supporting structure and bridges I will be using to glue down the guides. And I'll be just showing the process of gluing one guide down, and we follow the rest of the process for all of the other parts. I've got a line drawn on the baseboard where the glue line will be because I want to keep it to the center and right of where the carriage is going to be flowing. That way I reduce any of the squeeze out of the glue. I'm using folded over pieces of paper for my clearance guide between the front spacer and the carriage donut. Applying the glue to the baseboard and then spraying the guide with water because the Gorilla Glue cures with moisture. Set it in place with my shims front and back using the T-square as an alignment and then place the clamp bridges over the spacers and against the guide, and then of course the clamps there on top of the bridges. Once it's clamped in place, I pull the donut and the paper shim so that they don't glue to the board, and then get the T-square out of the way as well. I'll be following the same basic process for all of the supporting structure, being the other guide and the runners. Now a glue review and update. The guides and runners are glued in place, and I printed a new puck with an inset bolt so that the threads go down further into the carriage. The bolt head in the original puck was flush with the top and did not allow enough threads to protrude into the carriage. I also printed a new carriage which was slightly larger. The original carriage was too loose and it was coming up way too far out of the dovetail and not allowing things to tighten up. Now it is time to take the whole assembly over there onto the bandsaw, and that is where I'm going to attach the poplar miter slot boards to ensure they are lined up perfectly. Sorry for the poor lighting in this corner, but here we have the bandsaw with the blade removed and the two boards for the miter slot in place with wax paper insulating it from the table. I am assuming that the wax paper will prevent it from gluing itself to the table. We'll not know that until I attempt to remove it. I already have a bead of urethane glue across the boards and ready to clamp in place. And now here it is clamped on the table, and all I have to do now is wait till the glue sets up, and hopefully, if the wax paper did its job, I will be able to remove it from the table. The miter guide is glued on and ready to go, and now it is time to cut the blade clearance through the board. This is really simple, just by laying the new board assembly into the miter slot and then running the blade up to right about the center of the dovetail. Now that this is done, it's time to install the stop. The stop was printed on my 3D printer with 3 mounting holes to the base and 1 adjustable stop screw. There's a line drawn on the base where I want the center of the stop to be located. To avoid splitting the MDF, we'll drill a pilot hole. But first, using an oversized bit, we'll just put a little dimple in there to center the pilot hole drill bit. Now with the pilot drill ready, it will center itself in the little dimple that was from the oversized bit and then run it down to the depth of the screw. Once the first mounting screw is installed, I just repeat the process for the other 2 screws. And now we're ready for the first test cut. Now that I have a test blank, the first thing I need to do is find the center of the blank. This is simply done by connecting the 4 corners with a line. Once I have the center of the blank, I have to draw 90-degree angled lines on the center so that I can align the donut. The donut has 4 hatch marks cast right into it that I will be aligning on the 90-degree lines drawn on the center point of the blank. We will be attaching the donut with double-sided tape, and since it's the first time I'm doing this, I'm not certain if it's easier to put on the board or put it on the donut. So the first attempt, I'm going to be putting the double-sided tape on the board and then trimming it to size. After doing that, I think it's going to be easier to put the double-sided tape on the donut, but we'll try that later. Now I think it's time to go find out if my circle guide will actually cut a circle. On the bandsaw getting ready for the first test cut, and I ran into a problem. Once I had the distance set and putting the blank with the donut on top of the puck, it rocked back and forth. It should not have been doing that. A little investigation determined that it was the 2-sided tape that was going across the top of the puck, causing misalignment. What I'm going to do is print myself another puck that's a little shorter to allow for that extra room, but for now we're going to go ahead and cut this piece out and see how it works. I cut out the two-sided tape that was in the middle of the donut, and now it does not rock so bad. But I'm still going to need a shorter puck to actually finish this jig. Ready to cut, and just push the jig up through the saw blade until it comes to the stop on the adjustable stop on the jig. At this point, just start rotating the piece where the donut rotates around the puck. And what we end up with is a circle. So far, working pretty good. Couple of minor changes after that first cut. First one was the stop. The plastic body of the stop was actually contacting the scale on the saw, so I had to print another one that was just a little bit shorter to clear the scale. Also, here we can see a pointer I added on the carriage that I can use once I put an adhesive ruler on there and actually have it measurable. I have two marks on there, one 4-inch and one at 6-inch, and we're going to see how accurate I have that set up. And coming in a little bit closer, we can see the marks I put on the base once I move the puck out of the way, and a close-up look at what the pointer actually looks like. It just sits underneath the puck, in between the puck and the carriage. Time to go get another 4-inch blank and see how accurate it is.
Putting this on here, looking at this piece.
This end piece was on the one that I found online that I based my design on, and I've determined that it really is not needed. It functions as a stop for the puck, but the carriage and the dovetail also serves as a stop, so this one is redundant and can go away. Its only real purpose was a spacer for the guides, and just about anything can serve as the spacer for the guides. If I ever build another one of these jigs, I'll print 2 of the donuts and use them as the spacers. I'm set up to cut a 4-inch circle, and now it's time to see how accurate it cuts. The blank was cut at 4 1/8 inch square. Getting out the calipers, we can see it's just about a 32nd inch over the 4-inch target. And now, just for kicks, I'm going to tap the carriage over just a bit and see if I can get it to the actual 4-inch target. The light in this corner is pretty poor, and that's why the resolution is so low, so I had to get a flashlight so I could get a better look at how far I moved the puck. I have to be careful because the actual movement to make this correction is only 1/64 of an inch. At the time of doing this, I actually did not think it was going to make any difference. Once it's done shaving off that little bit, I get the calipers back out, and I was quite surprised. As you can see, it's almost exactly 4 inches. Now, if you remember, that dovetail cut right at the beginning was a little wonky. So next up, we're going to try to get that fixed. Because of that cheap, low-quality router table, the dovetail I cut was pretty wonky on one side. As you can see in this quick review, one side of the dovetail wandered quite a bit, causing issues with the carriage fitting, which has resulted in the carriage not being able to lock in place. So after I examined this, I had to think a little bit of just exactly how it is I'm going to resolve this problem. Worst case, I'll cut a dado down the whole length and then substitute in a piece of hardboard to function as the runner for the carriage. I decided I'm going to try plaster of Paris for my first attempt at fixing this wonky edge. I've got the plaster of Paris mixed up in a little cup and a popsicle stick to get it spread in place. I spread the plaster along the wonky edge, and then using the carriage with a long bolt screwed into the end of it to slide back and forth to form the new channel. The carriage was never meant to be moved like this, so it's a little difficult with that long bolt. The carriage gets stuck at angles as I go back and forth, but I managed to get it through and formed a channel which hopefully is going to correct this problem. I have no idea if this will be a temporary or permanent repair. If it fails anytime in the future, then I will go ahead and router all that out and then inset a piece of hardboard, likely poplar, to replace the Wonkey Dovetail. Well, that's what I'm going with. We won't know till it works until it sets up, and of course I clean up all of the debris that left over inside the slot and attempt to cut my final circle. If you attempt to build one of these, I highly recommend using at least pine for that slot. But like I've said, if I'm going to do this thing again, that slot will be out of poplar. The plaster's set up, sanded, and fit, and everything looks like it's going to work fine. This is a quick review set up before I make the cut for the 10-inch, not 10-inch, but 10-inch radius, but 20-inch diameter piece of MDF I need for my project. I have that front piece of plastic removed, and I think I mentioned before I have no idea what it was for. It was in the original video I saw of building a similar jig, but I've determined it's not needed, and now it's much easier to make my measurement lining up the scale with the edge of this clearance slot for the blade, and then straight out to the center of the puck. The video I watched that gave me the idea to build one of these was a long time ago, and I'll probably never see it again to understand what that piece was for. I've added the two pieces of MDF to the outside of the blade because there was some support needed in that area as the part is cut. Coming up is the final chapter of this build, which is where I cut the piece I needed for my current project. Keep in mind that when I did these videos, I had no idea if this was going to work or not. This overdubbed narration was done many months after the project was completed. Finally, it is time to cut the piece for my project. Here's the blank ready to cut my 20-inch diameter circle that I need for the forms for my potting bench. See the link above and in the description for the build for the forms for the potting bench and casting of the potting bench itself. And here is the print showing the final dimensions of the piece that I'm going to make. The 10-inch radius I have called out on the print is not critical, but we'll see how close it comes to with this new jig. And here is my new pointer that I printed out, as well as the donut that I'll be gluing to the blank. The blank is prepped with the donut taped in place, and now it is time to make the first cut. I'm going to cut this one slightly oversized just in case, and then trim it down to size if everything looks good. Set it up on the table with the miter guide in place, push it up to the blade stop, and then rotate it around.
Estimating it's about an 1/8 inch over. Something's hot. There we go.
Now the first cut is done and it looks pretty round. Let's get the tape measure out and see what size it is. Remember, I had it adjusted for about 1/8 inch over. Although you can't see the end of the tape measure in the video, it is exactly, but using calibrated eye on a tape measure, 1/8 inch over size. Now here's the real challenge. Can I trim it down just by removing 1/8 inch? Time to get it set up for the actual size of the circle. Since I'm only removing 1/8 and the puck is set at a radius, I'm carefully trying to move it over only 1/16 of an inch.
See what happens.
I think this thing's working pretty good. The fact that it's trimming off a little sliver of the edge. And now that the cut is finished, let's see where we're at. Grabbing the tape measure and finding the largest diameter, it appears as though Yes, it's only a 30 thousandths over my 20-inch mark, and that is about 1/32 inch. For the first actual cut on this jig, I'm going to have to call that a success.